Hello all. Today we are going to understand how to design a frequency sampling method filters for FIR. So we will be designing a filter. So let us take the problem. So the problem says that determine an impulse response of a filter using frequency sampling method. So they will always be emphasizing on the word called using frequency sampling method, and they will be giving us hd of e raised to j omega. So hd of e raised to j omega states is given as e raised to j omega into m minus 1 by 2 into omega for 0 less than equal to omega less than equal to pi by 2, let's say mod omega, and is 0 from omega ranging from pi by 2 to pi. So this is what is given to me, and they have given m is equal to 7. Now m over here is called as the order of filter. So the order of the filter is 7. Now let us understand how to solve this problem. So let us go to solution. So in solution, I will first make this generalized hd of e raised to j omega into specific value with m is equal to 7. So I get hd of e raised to j omega equals to e raised to minus j. When I put 7 over here, it becomes 7 minus 1 upon 2, which is 6 by 2, which is 3 omega, and is 0 from 0 less than equal to mod omega less than equal to pi by 2, and is equal to 0 from pi by 2 to pi. So now we got our hd of e raised to j omega. Next step, which is step 1 for us, is to sample the frequency. So how to do the sampling? For understanding the sampling, we need to draw the characteristics first. So let us draw the characteristics. On my x-axis, I will keep my omega, and on the y-axis, I will keep mod of hd of e raised to j omega. That is the magnitude. What is the magnitude over here? It is hidden. The magnitude over here is 1. Now this is my omega is equal to 0. Let's say this is my omega is equal to pi by 2. This is omega equals to minus pi by 2. This is omega equals to pi. This is omega equals to minus pi. Okay. Now my frequency the magnitude, that is 1, is for 0 to pi by 2. So 0 to pi by 2 here, 0 to pi by 2 there. So this is 1. From pi by 2 to pi, it is 0, it is 0. So there is a transition at pi by 2. So we can say that it's a low pass filter. Agreed? Now how should I divide this into smaller subsections or smaller parts? So let us understand only on one side, or let us shift this and make this whole graph from the scale of 0 to 2 pi rather than making it from minus pi to pi. Let us make on one side, that is 0 to 2 pi. So if I make this graph from 0 to 2 pi, it will look like, again I have omega over here, this is 0, and this is mod of hd of e raised to j omega. So let's say this is my pi by 2, and let's say this is my 2 pi and onwards. So I will go from 0 to pi by 2 straight. From pi by 2 to 2 pi, it will be will be 0. At 2 pi, I will get back my high value because omega is periodic with periodicity of 2 pi. So after 2 pi, 2 pi plus pi by 2 will be the next cutoff. Okay, so if I extend this ideology the same way, then the cutoff will come at value 2 pi plus pi by 2. There I will get the second cutoff, or I'll draw like this, and then I will have to reach here till 4 pi, right? And at 4 pi I will get the high value again, and this is going to repeat itself again and again and again at an interval of 2 pi. Now let us sample between 0 to 2 pi, because after 0 to 2 pi, whatever happens is the repetition of what is happening in between 0 to 2 pi. So let us sample the sequence into 0 to 2 pi. Now we know that omega is equal to 2 pi k by n. In problem they have replaced n by m, where we know that n is the order of the filter, and here they have given m as the order of the filter. So they are one and the same. So if I put or substitute the value of m, I am going to get 2 pi k by 7, which is omega. Okay, now from the problem I know the value of omega at 0, I know the value of omega at pi by 2, and I also know the value at 2 pi. Correct? So let us put first at omega equals to 0. So if I put omega is equal to 0, I am going to get 0 equals to 2 pi k by 7. So multiply over here, it will be 0, divide any number is 0. So here I am going to get k as equal to 0. So at omega is equal to 0, k is also equal to 0. At omega equals to pi by 2. So I will replace in this formula as pi by 2 equals to 2 pi k by 7. If I take it up, then it becomes 7 pi by, this will be 4, equals to pi k, right? 7 will go up, 2 will come down, and then here pi k. So pi will get cancelled, and you will get the value of k as equal to 7 by 4. Now 7 by 4 will be 1 point, because it is 7, 4 ones are 4, so 3 pending, 0.30. So you'll get 7, 4 6 or 4 sevens are rather 28. Okay, and 2 remaining, so 1.75 is the value of k. Now k is always an integer, so this will always be an integer value. Now how to obtain an integer value from 1.75? So from 1.75 I will neglect 0.75. So we will not consider 0.75, and we will only look after what is coming before point. So here k is equal to 1 for omega equals to pi by 2. So that is a relation. Okay, here k is equal to 0 for omega is equal to 0. Here k is equal to 1 at omega is equal to pi by 2. So on the x-axis, if I keep k, then k will be 0 over here, and here it will be 1. What values of integers k will take between 0 to 1? Nothing. So I will have one sample at k is equal to 0, the other sample is at k is equal to 1. Let us see what happens at 2 pi. So if I take frequency at 2 pi, so I will consider omega equals to 2 pi. Then I will get 2 pi equals to 2 pi k by 7. So this 2 pi will get cancelled, and k will be equal to 7. But from DFT formula, we know that k can only take 0 to 6 values. So we know that k can take only values from 0 to 6. It cannot take value from 0 to 7. So at 2 pi the value is 7. So let us see how the graph will look like now. So I was having the value going from, let's say this was omega, and the values were going from pi by 2 to 2 pi. At 2 pi I will have back my the value to be going at 1. So this is my 1, right? So I have one sample at this value. Let's draw with some other color. Then I have another sample at this point, and I have the 7th sample at this point. So this is k is equal to 7, this is k equals to 1, and this is k is equal to 0. That means k is equal to 2, 3, 4, 5 and 6 should be between these values only, right? So this will be k is equal to 2, then 3, then 4, then 5 and 6 will be in this stop band region, right? So now I will have k ranging from 0 to 7. So let us write our h of k, because we know that h of k is equal to hd of omega or e raised to j omega at omega going from 0 to 0 omega for 2 pi k by 7. So with these values, let us write our h of k. So for h of k, I will get the values as e raised to minus j. Now I was having hd of e raised to j omega as e raised to minus j 3 omega. That was the value. Now I'll put omega ki jagah pe 2 pi k by 7. So when I put 2, it becomes 6. Then there will be pi k by 7, and omega was 0 and hd of k was 0 for some values. So hd of k will be equal to this function at k is equal to 0 to k equals to 1, okay, and 0 otherwise, or I can say 0 from k is equal to 1, or I would say 2, not 1, because at 1 there will be then discontinuity. At 1 you will have 2 values at one point, so it will not happen. I will have k is equal to 2 as a next value. So at 2 to 6 I will get the values as 0. So this is my h of k. Okay, now once I have received h of k, I have to apply. So next is step 3, apply IDFT. So IDFT with the special case, so that h of n will always be an even function, a real function. To do that, first I need to understand whether my h of my n is, that is the order is even or odd. Because order is 7, it is odd. So I have to decide, I will use h of n as equal to 1 upon n into the bracket h of 0 plus 2 times of summation k going from 1 to m n minus 1 by 2 h of k e raised to j 2 pi n k by 7. This will be my function, right? So if I put n is equal to 7, then I'll get h of n equals to 1 by 7. Then I will have h of 0 plus 2 times of summation k goes from 1 to 7 minus 1 by 2. So 7 minus 1 by 2 is 3. H of k e raised to j 2 pi n k by 7. I put it 7 over here in the previous step also, it will remain the same. Now let us open up this bracket and you'll get h of n equals to 1 by 7 h of 0 plus 2 times of into the bracket. I have missed. This is only if I take this much, then it will never give me always the real value. So this is inside a bracket called real valued only. This is also only real valued. We cannot take complex values. So this function is real valued. This function is also real valued. So let us say k is equal to 1 will be h of 1 e raised to j 2 pi n by 7 plus h of 2 e raised to j 2 pi n into 2 because k is 2 over here by 7 plus h of 3 e raised to j 2 pi n by 7 into 3 because k is equal to 3 over here, and this ends the bracket. After 2, I should never miss that it is a real part of this product. So real part of this plus real part of this plus real part of this, or you do all the calculations and take only the real part. Now I will use this functions and I will see that what is h of 3, h of 2 and h of 1 and h of 0. Substitute it, solve it for various values of n. I will get h of n. So let us solve it. So if I put k is equal to 0, my h of 0 will be 1 e raised to 0, which is nothing but 1. If I put h of 1, that is k is equal to 1, I'll get e1 e raised to minus j, right? E raised to minus j. 2 3s are, we have 6 over there. So 6 pi by 7, correct, because k is there over. And then h of 2 is equal to 0, and 0 multiplied by any number does not matter, and h of 3 also is equal to 0. So if you see the summation now, the summation comes as h of n equals to 1 over 7, okay. H of 0 is 1 plus 2 times of real part of, okay, h of 1, because summation starts with 1. So I will get 1 e raised to minus j 6 pi by 7, okay, into e raised to, we have into e raised to j, okay, e raised to j 2 pi n by 7, because here also k is equal to 1. So I will put 2 pi n by 7, right. Rest both the terms will go to 0 because its multiplier is 0. Now let us take the calculation further. So it will be 1 plus 2 times of real value of, if I multiply this, I am going to get magnitude as 1, and this will be e raised to j will be common from both the sides. Then I can pull out 1 by 7 also common, but let us keep it inside. Then you can pull out pi also common, and here you will get as 2n minus 6 pi by 7. Further we will do some adjustment, and I will make it like 1 by 7 1 plus 2 real part of 1 e raised to j. Let us pull out 2 also common, so it will be n minus 3 2 pi by 7 is the required transfer function. Now what I'll do is I'll change, I'll write according to Euler's formula. I'll write this e raised to j in terms of cosine and sines. So I will get value as 1 by 7 1 plus I will have now 2, no real part because I will directly write, or else let us increase one more step. So let us say real part of cos of the angle comes as n minus 3 into 2 pi by 7, okay, plus j sine of n minus 3 2 pi by 7. And then I have to consider only the real part, which is the cosine term. So it will be 1 by 7 to 1 plus 2 times of cosine n minus 3 into 2 pi by 7. So that is my h of n. Now whenever now my n will range from 0, 1, 2 to 6. That is the 7 samples that I want. So 0 to 6. So here now we have to go and put the value of n, and you will get h of n as a finite impulse response. So this is the design methodology using frequency sampling method. Thank you.